The multi-level interconnects and metallization in a state-of-the-art CMOS processes. Several typical 4 to 8 metal layers are used for creating the interconnections between the transistors and for routing the power supply, signal and clock lines on the chip surface. The availability of edible metal layers where each layer is electrically isolated from the neighboring layers by dielectric SiO2 allows higher integration densities for realization of complex instructions, and actually adds a third dimension that can be utilized very effectively in design. As mentioned earlier, the electrical connections between the layers are made by wires that are placed wherever such a contact is needed. Each wire is formed by creating an opening window in the isolation oxide before each new metallization step, and filling the oxide opening with a special metal plug, usually Ensign. Following the creation of wires, the new layer of metal deposition and subsequent patterning forms the metallization level. It should be noted, however, that the chip surface is highly non-planar as a result of previous process steps to create the transistors, including N-well and P-well for formation, local oxidation and gate formation. It is not desirable to deposit multiple metal interconnect lines directly on this uneven topology because the deposited metal layer may exhibit localized thinning and discontinuous at uneven surface edges. Photolithography of non-planar surfaces is also difficult and imprecise. The surface non-conformity problems becomes even more pronounced with each additional metal layer, where successive accumulation of surface features such as steps may eventually result in pronounced hills and valleys on the chip surface. To avoid the problems associated with non-planar surface topology, the surface is usually planarized or flattened before each new metal deposition step. A fairly thick SiO2 layer is first deposited on the wafer surface to cover all existing surface non-uniformities. The top surface of this thick oxide layer is then planarized using one of several techniques such as glass reflow, heat treatment, HBAC, or chemical mechanical polishing (CMP). This last method, CMP, which involves actual polishing of the wafer surface using abrasive silica slurry, is being commonly adopted in the semiconductor industry in recent years. It allows the creation of successive layers of metal interconnection on chip, with each new layer being deposited on panelized oxide surface. Figure shows the scanning of microscope SEM cross-section of multi-level metal interconnects fabricated with SMP technique. Here you can see the figure actual cross-section of a modern IBM's power PC chip nodes the metal layers of the metal uh, node the multiple layers of metal for wiring above the silicon surface. The active parts of the transistors are barely visible to the bottom of the photograph, reprinted with permission of integrated circuit engineering corporation. um, Engineering Corporation. Thank you.